The second, so at first we have to deconstruct the topic, then we have to prioritize the topics that we have to learn. The stage three is learning. So in the learning, it's good that we ask the why, we ask the reasons behind the topic to understand the topic very well. And we also have different learning tools to do that. And the last stage is retrieval and feedback. So after learning everything, we just close the topic, and we need 5 minutes, 2 to 5 minutes to retrieve what we understood. Hello everyone, my name is Ali, and in this series of videos, I want to talk about how we can use different design methodologies when we are interacting with Gemini or ChatGPT or any generative AI that we have. So in this series of videos, we focus on this topic. So let's see what I mean by saying that we use design methodologies to interact with AI. Uh, let's bring an example. This is a Gemini. This is like the normal, simplest version of Gemini that we have. This is not premium. This is like simple version. Let's ask a question. How to become a fast learner? Okay. This is a really simple prompt that we usually input into the Gemini or ChatGPT and everything. So how to become a fast learner? Let's see what the answer is. Becoming a fast learner isn't about having a higher IQ. It's about upgrading your mental operating system. Most people try to learn by remote memorization, but the brain actually thrives on connection and retrieval. Okay, here is the roadmap to help you digest new information at 2 times speed. The, the Feynman technique, named after physicist Richard Feynman. This is the unlimited uh, litmus test for deep understanding. If you can't explain it simply, you don't understand. Step one, choose a concept you want to learn. Step two, pretend you are teaching it to a 10-year-old. Step three, identify the gaps in your explanation where you use jargon or got stuck. Step four, go back to the source material to fix those gaps. Interesting. This is my first time to actually use the topic. So I use actually the traditional way, and then we use it design methodology method to interact with data. So it was interesting technique. I didn't know. Leverage the spacing effect. Cramming is the enemy of long-term retention. Your brain needs time to knit new neurons together. Instead of studying 4 or 5 hours in one day, study for 30 minutes over 10 days. So leverage the spacing effect. By reviewing information just as you are about to forget it, you interrupt the forgetting curve and solidify the memory. Active recall vs passive review. Most people highlight text or reread notes. This creates an illusion of competence. To learn fast, you must force your brain to work. Don't reread the chapter. Do close the book and write down everything you remember. The act of retrieving information strengthens the neutral pathway more than the act of consuming it. The 80-20 rule in almost any field, 20% of the concepts provide 80% of the result. If you are learning a language, focus on the 1000 most common words first. If you are learning coding, focus on logic and loops before memorizing specific libraries. Identify the power concept and master them before moving to the fluff. How to become fast learner. Okay. Okay. So in the environment-based design or EBD, we first need to define what do we mean by fast learning. So what is fast? So at first we define the topic. So when we say what is fast learning, we mean what is the life cycle of the fast learning, or what is the events that we go through and become a fast learner, or what is the process of the fast learning, what is the process of learning fast. So we need to answer this question. Okay. So in environment-based design, at first we define the topic, and when we are talking about definition of the topic, we are talking about the process of the topic. So at first we make some definition, we provide some definition. Please define fast learning. Okay, what is the definition? In the simplest form, fast learning is the process of maximizing the rate of acquisition and retention of new knowledge or skills while minimizing the time and effort spent. Mhm. High efficiency encoding, strategy deconstruction, delivery. Okay, but this definition is sufficient. So, what is fast learning? Why do we mean by fast learning? Gemini said it is the simplest form. Fast learning, often called meta learning or learning how to learn, is the process of maximizing the rate of acquisition and retention of new knowledge or skills while minimizing the time and effort spent. So it says about the process, as you can see here. Uh, in its simplest form, fast learning is the process of maximizing the rate of acquisition and retention. Okay. So what is the process of learning? This is the other question that we also had it on that definition. Let's ask again. What is the process of learning fast? Explain stage by stage. Okay. So, stage one, fast learning isn't a linear path of reading more books. It's a systematic attack on a subject. It's interesting. It's a systematic attack on the subject. To learn something at two times or three times the normal speed, you need to follow a structured loop. So this is a structure. Okay. And if you follow it, it could be really helpful. That focus on high impact information and immediate feedback. Stage one, the deconstruction, 80-20 analysis. Before you touch a textbook, you must break the subject into its smallest possible components. Most people get overwhelmed because they try to learn everything at once. Identify the minimum effective dose. Find the 20% of concept that will give you 80% of the result. So deconstruction, it says that focus on the 20% of the concept, which is the most important. Selection and prioritizing. Now that you have the pieces, you must decide which ones to learn first to create. Okay, first we make it piece by piece, we break it down, and then we focus on the plan, prioritize. Now that you have the pieces, you must decide which ones to learn first to create a snowball effect. Logic sequencing. Learn the things that make other things easier. Learn basic logic before learning a specific coding syntax. Stakes. Set a goal that requires the skill immediately. If you have to give a speech in a week, you will learn the material much faster than if you are just studying for fun. Encoding. This is the input stage. The goal here is to move information from your short-term RAM to your long-term RAM, hard drive. Analogy building. Connect the new concept to something you already know. The Feynman technique: explain the concept out loud as if to a child. If you stumble or use a big word to hide your confusion, you haven't encoded it. Visual mapping: create a mind map. Our brains are evolved to remember spatial layouts and images much better than abstract text. Retrieval and feedback: this is where the actual learning happens. Real learning is uncomfortable. If it feels easy, you aren't learning fast. Active recall: instead of rereading your notes, close them and try to recreate them from scratch. Spaced repetition and immediate feedback. Okay, so now we have the stages. Okay, stage one: deconstruction. Stage two: selection and prioritizing. Stage three: encoding. Stage four: retrieval and feed. Okay, so we have four stages for learning fast. So in the environment-based design, then we have to focus on every stage and find out the environment, including tools, including nature and people involved in the environment. So let's see what happens. Let's focus on the first stage, deconstruction. So we don't have nature and human, because human is ourselves, but we might have tools and techniques there. So let's focus on the first stage, deconstruction. Please let me know all the tools or techniques related to the deconstruction. This stage. 80-20 rules, the stake method, expert interviews, and semantic trees. Search for, and so in the deconstruction, we want to deconstruct the topic to different parts. 80-20 rule. This is the golden rule of fast learning. You must identify the 20% of the material that will give you the 80% of the mastery. Sorry, okay. How to do it? If learning a language, don't start with grammar rules. Search for 1000 most common words. Those words make up the bulk of every everyday conversation. Focus on the 20% of topic that covers 80% of the result. It's fantastic. Okay. Stakes method. So it says that, yeah, it was really interesting. Let's see the other two. The stakes method, outcome mapping. Deconstruction works best when you work backward from a specific goal. The technique: ask what is the smallest unit of success in this field. Cooking, making one perfect omelette, not learning the history of the French cuisine. Okay. Deconstruction works best when you work backward from a specific goal. Okay. Coding, building a to-do list app, not memorizing the entire Python library. The tool, create a minimum viable skill list. Okay. If you can do these five things, you are the function. This is another technique for deconstruction. Create a minimum viable skill. There's something that we can do and it has a result, not just theoretical. Something that we have something effective out of it. Expert interview, DSS framework. The team Ferris popularized this via the DSS method. Deconstruction, selection, sequencing mistakes. The best tool here is talking to someone who is already good at a skill. The magic question, ask an expert. If you had to teach me this in only 48 hours, what would you cut out and what you tell me to obsess over? So in this stage, we want to deconstruct the workload. Alternative, if you can find an expert, look at table of contents in three different dummies or complete guidebooks. See which three or five chapters appear in all of them. All of them, those are logo books. It's interesting. Yes, this technique is also very good. Semantic trees. Elon Musk often speaks about viewing knowledge as a semantic tree. You must understand the trunk and big branches before you get into the leaves. The technique, draw a tree. The trunk is the fundamental truth. In physics, this is F equal to ma. The branches are the subtopics. The tool, mind mapping software. The rule, this is another technique. So it was all the tools for the first stage deconstruction. Uh, and we also have the human involved, find an expert and ask these magic questions. If you had to teach me this in only 48 hours, what would you cut out? And what would you tell me to obsess over? Okay, the second stage is selection and prioritizing. So according to environment-based design, we go through every stage and find out the tools related to that stage, the human related to that stage, and nature related to that stage. So in this example, we don't have human because human is ourselves. We want to learn fast. And we also don't have too much nature. Nature means the weather, like the snow, it's a nature. So we don't have nature, so we just focus on the tools. Okay, so we just use this comment again. Let's focus on the second stage, selection and prioritizing. Please let me know all the tools and tools related to this stage. Okay. Pareto filter. This is the primary tool for the selection in any skills. 20% of the sub skills will produce 80% of desired result. The techniques look at your list of deconstructed Lego blocks and ask which of these blocks are used most frequently in the real world. Mhm. So this is one technique we have. Application language, instead of learning grammar, select 1000 most common words. Application cooking, instead of learning recipes, select heat management and knife skills. Minimum effective dose MED, borrowed from the medical world. MED is the smallest dose that will produce a desired outcome. Anything beyond the MED is a waste of time and can actually lead to burnout. The technique defines competency strictly. If your goal is to play guitar at a party, your MED is 4 chords. Learning a fifth chord is overdosing and it slows down your path to your specific goal. The tool, the outcome checklist, write down exactly what you want to be able to do. If a piece of information doesn't directly contribute to that thing, it gets moved to the later pile. So it's the other technique borrowed from the medical world. MED is the smallest dose that will produce a desired outcome. Anything beyond MED is waste of time. So find out MED. Cinderella technique, identifying failure points. Selection isn't just about what to learn, it's about what to avoid so you don't quit. Tim Ferriss calls this identifying failure points. The technique asks why do most people quit this skill in the first 2 weeks? Example, okay, the specific fix consciously deprioritize the boring failures points if verb, okay. So the other technique, I didn't like this technique. It wasn't super clear for me. CAFE method. Once you've selected your 20%, you need to organize it using the CAFE acronym to ensure it's prioritized correctly for your brain. Compression. Can you fit the most important 20% onto a single one-page cheat sheet? Frequency. Based on your selection, what is the minimum frequency needed to not forget, and encoding. Sequencing, the order of operations. Once you have the right pieces, the order in which you learn them is a multiplier for speed. The technique implicit before explicit. Learn the feel before the theory. Example, in chess, don't learn openings first. Learn the in end game. Logical, okay, sequencing. Once you have the right piece, the order in which you learn them is a multiplier for speed. Okay, so these are the techniques for selection and prioritizing, and the stage three is encoding. So the techniques actually is already there. So let's see if we use actually this prompt. Do we have more tools and techniques or not? So let's use this prompt again. Let's focus on the third stage, encoding. Please let me know all the tools or techniques related to this stage. In encoding stage, you are moving information from your temporary RAM to your hard drive or long-term memory. So I didn't know if the construction was about what, encoding is about how. The goal is to transform abstract data into a neural language your brain actually likes. Okay, so let's make it clarified. The big three encoding techniques, elaborative interrogation, the why method. Don't just accept the fact, ask why it is true. Explaining the logic behind a fact creates a hook in your brain. It's a really good technique. I like it. So, okay. Dual coding, humans have separate channels for visual and verbal information. If you use both, you create two memory traces instead of one. Technique, never take text-only notes, always draw a crude diagram, symbol, sketch. Semantic mapping, your brain doesn't store info in a list, it stores it in a web. Mind map, connect new info to things you already know. These are the techniques, but I don't like them. So I just like in my notes, I just put the most effective ones and the most easiest ones. Memory hook, the memory palace method of Lossy mentally place the things you want to remember in a familiar room, like your childhood home, to recall them. Simply walk through the room. Peg system, link numbers to rhyming words. If okay, acronym, use acronym. Okay. The self reference effect, modern tools like Anki. Okay, this is just learning. This is just about learning. And the last, so learning techniques, learning tools, and the last is retrieval and feedback. So we use the prompt. Please let me know all the tools or techniques related to this stage. Brain dumping, the two things activity. Brain dumping, take a blank sheet of paper and write down everything you remember about the topic for 5 to 10 minutes. Only after you are stuck do you open your notes to see what you missed. Nice. Into retrieval. The two things activity. At the end of every study session, force yourself to recall and write down the two most important things you learned. This forced an immediate retrieval event. This was nice. Active recall via questions instead of writing notes as statements. Write them as a question. This turns your own notes into a good testing tool. Whiteboard recall. Draw a diagram or process from memory on a white. Verbal explain it as you draw. If you stumble, that your feedback signal to review that specific. Smart spaced repetition tools, SR tools, track your forgetting curve and prompt you to retrieve info exactly when you are about to lose it. And key, and okay, we can use these tools, creating brutal feedback loops, AI tutors, transfer task, the new notes memos, write one page, how to, okay, they are the different tools. So let's compare the two way of interaction with the Gemini. The first way, as you can see, how to become a fast learner. Okay, we just have specific tools, the Feynman technique. Leverage the spacing effect, active recall, 80-20 rules. See? And when we use a design methodology, in this design methodology, we use environment-based design. So at first we define the topic and then we asked about the specific stages of the topic, and then we used every stage to find out tools in that stage. We had too much concept and too much tools. So in general, for the fast, what can we do for the fast learning? At first, in the first stage, for the fast learning, we have to deconstruct the topic to different parts. And now we have the topic, we have the too much uh, too much small topic, too much small topic. In the second stage, stage two, we select and prioritize. Select and prioritize the topics that we should learn. So we have different technique to do that. Like we can ask some expert which topics are the most important, or we can use the like different chapter books and find out the most important topics they are in common, and or use the actually this question, which of these blocks are used most frequently in the real world, so in the real example in the industry, which these which parts have been used. So the second, so at first we have to deconstruct the topic, then we have to prioritize the topics that you have to learn. The stage three is learning. So in the learning, it's good that we ask the why, we ask the reasons behind the topic to understand the topic very well. And we also have different learning tools to do that. And the last stage is retrieval and feedback. So after learning everything, we just close the topic, and we need 5 minutes, 2 to 5 minutes to retrieve what we understood. Just explain it for ourselves or write down the topic on the paper to find out what we learned. And after that, we can just go back, we can refer to the main topic, and then uh, we can compare what we learned and what we have to find out the gaps. So this is a retrieval. The other techniques is two things technique. So at the end of every study session, force yourself to recall and write down the most two important things you learned. This forces an immediate retrieval event and active recall via questions. Instead of writing notes as statements like photosynthesis happens in chloroplast, write them as questions. Where does photosynthesis happen? So write them as questions. This turns your own notes into the testing tools. And we have also various retrieval tools. So we have four important stages for fast learning: deconstruction, selection, and prioritizing. So the deconstruction, selection, and prioritizing, encoding, and retrieval and feed. By following these four stages, we can have a really fast learning process. Okay, this was the application of environment-based design. We used these design methodologies to interact with AI in a different method. I hope it was good for you and it was uh, helpful for you. Thank you guys.